You ever wonder how your phone can, instantly translate a sign in another language? It feels like magic, right? But it's not. It's an incredible field of AI called natural language processing. So in this explainer, we're going to pull back the curtain and break down the 4 key phases that let machines actually understand what we're saying.
And here is that ladder. These are the 4 essential layers of natural language processing, or NLP. We're going to start at the very bottom with lexical analysis, then work our way up through syntactic, semantic, and finally all the way to the top, pragmatic analysis.
All right, phase 1, lexical analysis. This is ground zero. It's the absolute starting point for everything. Before a computer can even begin to understand a sentence, it has to figure out what the individual pieces are.
So at this stage, the machine's job is to take a big chunk of raw text and chop it up into smaller, meaningful units that we call tokens. You can picture it like taking a sentence and just sorting every single word and even the punctuation into its own little box. This is the first crucial step.
And here's a super simple example of what that looks like. The sentence, "I love programming," gets broken down into 4 separate tokens. And you'll notice even the period gets its own token. This whole process is called tokenization, and what it gives us is a nice, clean, structured list that the machine can now pass on to the next phase.
Okay, so now we have our tokens. We have our list of ingredients. But, a list of ingredients isn't a meal, right? You need a recipe. And that's exactly what brings us to phase 2, syntactic analysis. Now that we have the words, we got to check if they're put together in the right order. This is basically the grammar police of NLP.
Syntactic analysis, which is also called parsing, is where the machine looks at that sequence of tokens to see if it follows the rules of grammar. It's figuring out the parts of speech. Is this a noun, a verb, an adjective? And then understanding the sentence structure, like finding the subject and the object. It's basically building a sentence diagram to make sure everything is where it's supposed to be.
This makes it super clear. Both of these sentences use the exact same tokens, the same words, but the machine can instantly see that only the first one makes grammatical sense. The cat sat on the mat follows the rules of English. Matt the sat on cat, well, that's just a random jumble of words. Syntactic analysis is the filter that catches these kinds of errors.
Okay, so the grammar checks out. We must be done, right? Well, not so fast. Welcome to phase 3, semantic analysis. Because just because a sentence is grammatically correct doesn't mean it actually makes any sense.
Let's look at this classic example. Apple eats a John. Now, from a grammar perspective, this sentence is totally fine. You've got a subject, apple, a verb, eats, and an object, a John. But it's nonsense. An apple can't eat a person. This is where semantic analysis kicks in. It checks if the sentence is actually logical, based on the real-world meanings of the words.
A really big part of semantics is dealing with words that have multiple meanings. The word bank, for instance. If you say, "I went to the bank to deposit money," the surrounding words, deposit and money, are clues. They tell the machine you're talking about a financial institution. But if you say, "We sat by the riverbank," the word river points to a totally different meaning. Figuring this out is called word sense disambiguation, and it's absolutely essential for true understanding.
Okay, we've made it. Our sentence is grammatically correct, and it makes literal sense. We've reached the final and honestly the most sophisticated layer, phase 4, pragmatic analysis. This is where the machine has to look past the dictionary definitions and figure out what someone really means.
Pragmatic analysis is where the AI has to stop being a dictionary and start being more like a detective. It has to use everything it knows, the context of the conversation, our social customs, just general real-world knowledge, to figure out the intended meaning. It's the art of reading between the lines, which, as you can imagine, is incredibly hard to teach a machine.
This simple question is the absolute perfect example. Just think about it for a second. When someone says this to you at the dinner table, what are they really asking?
And here it is. The literal semantic meaning is, are you physically capable of passing the salt? The pragmatic, or intended meaning, is actually a polite command. Please give me the salt. A truly smart system needs pragmatic analysis to know that the right response isn't to just say yes, but to actually pass the salt. That's the difference.
So, let's put it all together now. Let's follow one sentence all the way through. She went to the bank. Okay, step 1, lexical analysis breaks it into tokens. Step 2, syntactic analysis confirms, yep, the grammar's good. Step 3, semantic analysis looks at the context and decides bank means the financial building, not the edge of a river. And finally, step 4, pragmatic analysis understands this is just a statement of fact. 4 steps, from pieces to purpose.
So why does any of this matter?
Well, because this four-phase process is the engine running inside so much of the technology we use every single day. Every time you do a Google search, every time you talk to Siri or Alexa, every time your email corrects your grammar, it's all powered by these layers of analysis, all working together in a fraction of a second.